Hello guys, welcome to Dan's IT Network, and for today's video, we'll talk about PVST. PVST stands for Per VLAN Spanning Tree Protocol. Okay. Before we proceed, I assume that you already know how STP function, because if you do not know how is the STP is working, then you'll be having a hard time in understanding this video tutorial about PVST. And I suggest you to watch my free video tutorial about STP. Okay, let me put the link on the description below for you to watch and learn. And another thing that we need to consider is we should also know how to create a VLAN and set up a trunk port, since we'll be talking about per VLAN span tree protocol is we will be you know need to create a VLAN on this network. So if you do not know how to create VLAN and set up a trunk port on a VLAN, then I recommend you to watch my video tutorial on how to create VLAN and set up a trunk port. Well, it's just basic understanding, and I will also put the link on the description below for you to watch and learn. Okay, let's proceed. So let me assume that you do know the STP and you know how to create a VLAN and set up a trunk port. Okay, so PVST. This stands for per VLAN span and tree protocol. It has the support IEEE 802.1q protocol, and it is running one STP instance per VLAN. Okay, what is the difference in a PVST and STP? Well, most likely their function is the same. Okay, the only difference is in the STP it can run a one STP to all VLANs, while in a PVST is it can run one STP per VLAN. So what do I mean by that? So for example, on a VLAN one, so we all know that VLAN one is the default VLAN. Okay, and if we will activate the PVST, is there will be an STP that will run on the VLAN one. So the STP needs to elect which one is the root bridge, okay, and it needs also to assign what are the root ports, designated ports, and non-designated ports, which is on the VLAN 1. And if we will create another VLAN, let's say VLAN number 2, then another separate STP will run. So it needs to select another root bridge for VLAN 2, and it also needs to assign another root ports, designated ports, and non-designated ports on the VLAN 2. Okay, so to make it short, it runs STP separately. Okay, so per VLAN. So VLAN 1, it runs one STP, and then for VLAN 2, another STP. So separate STP is running. Okay, that's it. All right, and on this network design, we have here a four switches. So switch 1, switch 2, switch 3, and switch number 4. And the by default, PVST is already active on each switches. And to show you, I'll open this switch 1 command line interface, hit enter to get started. I'll type here enable, okay, and then I'll type here show space run space bar space bar space bar space bar to see the information below. Scroll up and you will see here that the spanning tree mode PVST is already active on this switch. But if in case that if on your end is you're getting a different information, you're getting rapid PVST, then all you have to do is to type COMT to go to the global config mode, and then type this command spanning dash tree space mode, and then space question mark, right? Then all you have to do is to type the PVST. Okay, so I'll type it for you, PVST. There you go, and then Control C. Then let me save the configuration, and then you can try to type the show run again to view the running configuration and for you to double check. if it's running. And as you see in here that the PVST is active. All right. Okay. And another thing that I did on this network is I create a VLAN 2. So every switches has a, VLAN 2. And by looking on this computer over here, I already registered their IP address. Okay, so I put them on a one network, so 1.100 on this PC, and then 1.101 on this PC, and they are already on the VLAN 1, which is the default one. And I did not configure anything on this F0/5 and F0/6 because they are already registered into a VLAN 1, which is the default one. Okay, and on this computer over here, I put them on the 2 network. So 2.100 over here, and this one is a 2.101. Okay, and I put them on the VLAN 2, this F0/5 and F0/6. I registered them to the VLAN number 2. And just to show you the proof, I'll open this switch number 3. Let me spread this. I'll click this command line interface, hit enter to get started, enable, and then I'll type here show space VLAN space brief, and you'll see in here that this is the VLAN 2 and it's active, and the F0/5 and F0/6 is registered on the VLAN 2. The rest are registered to a VLAN 1. So we have two VLANs, the default VLAN 1, and then um, the VLAN 2 that that we create. Okay, and I'll close this. So on this network, these switches are actually talking to each other using the STP messages. STP messages, those are the BPDU, okay, or it stands for Bridge Protocol Data Unit. And these are frames that are exchanging between switches to ensure that only one path exists. Okay, so they are sending an update of BPDU frames every 2 seconds. Okay, that's what we call hello BPDU packets, right? So trying to they are updating each other, and they're trying to elect which one of them should be the root bridge. Okay, all right. So what we'll do in here is on this switch one, we'll make this as the primary root bridge for VLAN 1, and we'll make it as the um, secondary root bridge for VLAN 2. Okay, and this on the switch 4, we'll make this switch 4 as the primary root bridge for VLAN 2 and secondary root bridge for VLAN 1. All right, and then after that, we'll do some experiment and observation. So I'll open this switch 1. Let me spread this. I'll type here CompT, and let me put this in here so that you'll see. Okay, so I'll type this command, spanning dash 3 space VLAN 1. Okay, and then space root. We'll make this as the primary. Okay, this is the command. All right, well, I will erase this. Let's pretend that we don't know the next command. So after this root, I'll type here space, and then I'll type question mark for you to see what are the available commands that you can use though. So since our goal is to make this switch W1 to be the primary root bridge for VLAN 1. Okay, so that's why we need to type in here primary, enter, and then I will use the up arrow key to use the same command, because I'm just going to change this VLAN 1 to number 2, because we need to make this VLAN 2 as the secondary root bridge to switch W1. Type secondary, enter, Control C on the keyboard, and let me save the configuration by typing right. There you go. I'll close this, and I'll open this switch 4. Let me spread this. Command line interface. Hit enter to get started. Type enable to go to the privilege mode. And then I'll type here CompT to go to the global config mode. Oh, sorry. I added this, this, what do you call this? Invalid prompt. So I only need to type comp and just T. Okay, so Comm T to go to the global config mode, and then type this command spanning dash 3 space VLAN 2, then root. So we'll make this as the primary, and I'll use the up arrow key. I'm just gonna change this then VLAN 1, because we need to, you know, make the VLAN 1 as the secondary root bridge on switch number 4. Okay, so I'll change this primary then to secondary. When we say secondary, this is acting like a backup. All right, there you go. I'll hit enter, control C, and let me save the configuration. All right, so now let's test though. Let's check this switch 1 is this is already the root bridge for VLAN 1. Okay, let's see how is the PVST function on every switches. So let's check first this SW1. I'll open the switch. So switch 1, all right? And then I'm going to spread this. I'll type here. So I am already on the privilege mode. I just need to type show space spanning dash 3. Okay. And space bar to see the information below. Space bar. Okay. Okay. And then scroll up. So as you can see here, this is the last command that we input. So show span tree, right? And it gives us the information about the VLAN 1, right? As you see in here. And it tells us, right, as you can see, root ID versus the bridge ID, their MAC address is the same, okay? So by looking on their MAC address, though, we can say that this is the root bridge because the MAC address are the same root ID versus the bridge ID, and it tells us that this message, this is the root, okay, and it gives us the information as well about the status on the port on the VLAN 1. So the F0/1 is on the designated port. It is forwarding, and it has a port path cost of 19. Okay, it is 19. It's because it is a fast Ethernet, and when we say if it's a fast Ethernet, it is 100 megabit per second. All right, and it's a full duplex. So if it's 100 megabit per second, okay, it should have a port path cost of 19. Okay, all right, okay, and then let me scroll it down, and you'll see in here that it also gives us another information, okay, for the STP. So another STP is running on the VLAN number 2. Okay, so this is on the VLAN 1. Right? So there is an STP running on the VLAN 1, and there is also another STP that is running on the VLAN 2. And on the VLAN 2, it gives us the information that definitely the spanning tree is enabled, right? And it gives us that the root bridge on the VLAN 2 is this MAC address, all right? So 00E0.A329.01E5, okay? And this bridge ID, this is the information that's we have on this switch W1. So this switch W1, this is the bridge ID. Okay, so this is its MAC address for the switch W1. And as you see that they are not matched, all right? Well, if they are matched, then definitely that this is the root bridge. Okay, and let's check the status on the port. As you can see in here, we have a different status on the port, all right? On the F0/1, it tells us that this is the root port, and the F0/2, this is the designated port forwarding. While on the VLAN 1, it tells us that the F0/1 is the designated port. So again, though, we are running a separate STP, and it gives us a different information about the status on the port. Okay, so F0/1 is the root port. Let's see. So on the VLAN 2 right here in the SW1, this F0/2 is acting as the root port. Okay, and this is the designated port. Okay, that is very informative, and I'll close this. Let's go on to the switch number 4. Let's use the same command, show spanning dash free, okay, space bar, and then let's see. So this is on the VLAN 1. As you can see in here, that this is not the root bridge, okay, because we did not set this VLAN then as the root bridge for this SW4, right? So root ID versus the bridge ID, they have a different MAC address, okay, as you see. And by looking on the status on the port, it says that the F0/1 is acting as the designated port, right? It's forwarding. There you go in here on the VLAN 1. And then on the F0/2 is acting as a root port, which is in here. Okay. All right. And let's check the VLAN number 2. So this is the VLAN number 2. Okay. This is the STP that is running, on the VLAN number 2 under the SW4. Okay. And root ID versus the bridge ID, as you can see here that we have the same MAC address. So it tells us that this is the root bridge on the VLAN 2 under the switch number 4. Okay. And by looking on the status on the port on this switch number 4, it tells us that the F0/1 and F0/4, they are all on the designated forwarding. Okay, you have to always remember, if it is the root bridge, all port should be on the forwarding mode. Okay, there is no root port on a root bridge. Remember that. Okay, and I'll close this. Let's check then on the switch number 2. I'm sorry. Okay, there you go. All right, there. Okay, so switch. How come that it's moving? All right, and then I'll just have to click this. Okay, there you go. And then command line interface, hit enter to get started, enable, and then show spanning dash tree. There you go. And as you can see here, so let's go first on the VLAN 1. All right, so this is the VLAN 1. Okay, and it tells us that the root ID, meaning that this is the root bridge information. Okay, so it tells us that it can actually see the root bridge, okay, on this switch W2, right? It can see the root bridge, the 0090, okay, dot 2158, etc. Okay, and cost 19, and port is a fast Ethernet 3. Okay, so by looking in here, right? So switch to, this is the root bridge for VLAN 1, all right? So for this switch to reach the switch number 1, so it is using a fast Ethernet port. So the cost is 19. So that is why it shows in here that the cost is 19. So for this switch to reach the switch 1, it needs to have a port cost of 19 because it is connected on the fast Ethernet port, switch to switch. Okay, it's 19. And then port is a fast Ethernet 0/3. As you can see here, it needs to go out to this F0/3 to reach the SW1. Okay, all right. And this bridge ID, this is the MAC address, okay, on this switch number 2. Okay, and as you can see here, that all ports are designated forwarding except for the F0/3. Okay, so let's see. So this F0/3 is acting as a root port on a VLAN 1, okay? While the other, they are all on the designated forwarding mode. Okay, there you go. And let me close this, right? And I'll open the last switch, switch number 3. Hit enter to get started, enable. Same command, show spanning dash 3, space bar. And let me spread this. right? And let's check first the VLAN 1. Okay, so as you can see here, we got the same information. So in here, the cost is at 38, all right? So we are on the SW3, and we do know that the root bridge is the SW1 under the VLAN 1, right? Okay, so the root port on this SW3 is the F0 slash 3. Okay, so this is the F0 slash 3, all right? So it actually needs to go to the switch 4 and then switch 4 to switch 1 to reach the root bridge, all right? And as you see, the cost is 38, right? 38. Okay, so this is cost 19. So 19 plus 19 is equals to 38, right? That's it. So port fast ethernet 0 slash 3, it needs to go out to this interface to reach this root bridge, which is, you know, the on the VLAN 1, right? So that's how port path cost work. Okay, and then the bridge ID. Okay, this is the information about the SW3, right? And as you can see here on this app, on the switch number 3K, this is the root port, and this is the alternate port. So what will happen here, if in case that the F0 slash 3 went down, then the F0 slash 2 will take place. It's because the F0 slash 2 is acting as the alternate blocking. All right. When we say alternate blocking, this serves as you know, the job is to take responsibility if, I mean, the job of this alternate port is to, if the root port went down, okay, then it will take, you know, it will take place. All right, that's it. And then let's check on the VLAN number 2. All right, so as you can see here, it gives us the information about all of this port. All right, okay, so on the VLAN 2, it says that all of them are forwarding except for the F0 slash 3. This is on the VLAN number 2. Okay, and you might be asking though, on the VLAN 1 is, it only gives us 2 ports. Well, why? It's because this ports in here, the F0 slash 5 and F0 slash 6, are registered to VLAN 2. That is why they cannot be seen on the VLAN number 1. Okay, so they are only showing then on the VLAN 2, and this is their you know status. All right. Okay, and there you go. So that's actually how the PVST is working. Well, you can try to play around with the network. Okay, let's say if you want this switch 2 to be the root bridge for VLAN 2, or let's say VLAN 1, you can try to do that. All right, and good luck. If you like this video, please do subscribe to my YouTube channel, Dance IT Network, to get more updates about Cisco CCNA. And if you have any questions, suggestions, or requesting for any video tutorial, then you can email me, danceitnetwork@gmail.com. Thanks for watching. Bye.